So, in our previous discussion, we discussed in details about data models. So, data models is a description, portrayal, explanation, and view of the real world. A data model is a conceptual idea as opposed to the way that the data is actually stored in the computer, which is known as the data structure. And data formats are the actual computer structures we use to store and display information digitally. So to store and display textual information, two familiar data formats are, you all are familiar with the doc form or txt form, which are being used to display, for example, textual information. Similarly, to store and display spatial data examples, you might have heard about shapefile, the DWG format or GDB format, or very commonly the Google Maps, etc. in KML format or WMS. These are some examples to store and display the spatial data. In this section, we would learn about the different spatial data formats. Before that, we would look into the information organization of geographical data. The geographical data where the most basic element of information organization is called as basic graphical element. There are three basic graphical elements which we have discussed earlier also. They are known as the point, line, also referred as an arc, or polygon, which is also referred as an area. These basic graphical elements can be individually used to represent geographic features or entities. For example, point, we may represent a well, or any benchmark which represent the spot height of that particular location. The line entity may be the road segment or river, etc. And the polygon may be any lake or a forest area, etc. They can also be used to construct complex features. For example, the geographic entity India on a map is represented by a group of polygons of different sizes and shapes. For example, if you just look into a map of India with the political state boundary, this argument can be very easily understood, that how the complex features of political boundaries in the form of state boundary, they are represented in the form of polygons which are different in size, and they are all different shapes. For example, the USA state boundary, they are radial in nature. They are geometrical in nature. They are being represented with straight line. But in our country, the political boundaries, the state boundaries are not the geometrical boundaries. So they are a good example of different size and different shapes. So in this diagram, examples of graphical representation of point, line, and area are shown. This is known as the feature model. The examples of point feature is on the left side, which suggests the elevation of that particular spot. We can call it as a benchmark or spot height of that particular location. The feature through point, in this feature model, the point information is represented as a elevation mark, elevation above the mean sea level. A line feature is represented, the example is any river, and an area feature can be represented as, the example can be a lake feature. It is very easily can be identified in this diagram. So just if we can look into some of the important characteristics of these point feature, line feature, and area features. A point feature has neither length or width. and hence it is said to be a zero dimension feature. A point feature represents as single location. A point is the simplest graphical representation of an object because it is zero dimensional. Points have no dimensions but are indicated on maps or displayed on screen by using some symbols. The corner of a property boundary is a typical point as it is the representative coordinate of that building. Here, as we discussed earlier, if you recall in some previous discussion, we have said that the scale of viewing determines whether an object is defined as a point or an area. For example, if you recall earlier, I gave you the example of the state of Delhi or the city of Delhi. In the map of Delhi, the Delhi city is a polygon entity, area entity. Whereas in a map of world, if we want to depict the city of Delhi, it can be depicted only in point entity, as point entity. So that is where we are saying that this point, line, area entity, they have great relevance, great relationship with the scale also, especially in the digital format. In a large scale representation, a building may be shown as an area, whereas it may be a point symbol if the scale is reduced. Similarly, the line features, line have length but not breadth. Therefore, it is one dimension. The point entity, we said that it is the zero dimension because it does not have any length or width. It's just being represented in the form of a point. But line feature, it has the length, it is a linear feature, so it has one dimension. They are used to represent the linear entities, as we are giving you the example of river, roads, railway networks, etc. Even power cables can also be taken as one of the example. A line feature is a set of connected ordered coordinates representing the linear shape over a map. The object that may be too narrow to display as an area, such as road, or feature within a width with no width, such as contour lines. Whereas area feature, we represent area objects which have two dimensions of length as well as breadth. An area feature is a closed figure whose boundary encloses homogeneous characteristics such as a state boundary, state political boundary, in any region, the soil type, or the example which we showed in the diagram, the lake. Again, the physical size in relation to the scale determines whether an object is represented by an area or by a point. An area is delineated by at least 3 connecting lines, each of which comprises of a large number of points. In databases, area are represented by polygons, that is, plane figures enclosed by at least 3 straight lines intersecting at a like number of points. Therefore, the term polygon is often used instead of area. So now in this diagram, you can have a good idea of how spatial information is stored. The geographic information has dimensions. If you look carefully in this particular diagram, starting from the left side, the areas are two-dimensional, and this area consists of several lines which are one-dimensional, and these lines consist of several points which we can say as zero-dimensional, and each point consists of a coordinate pair. Coordinate pair means that one location is on x-axis and another location is on the y-axis. Very commonly we use latitude and longitude. So now think, if we have any rectangular area entity, how it may be represented? Here in this diagram we are showing an area entity where we are saying that it consists of many lines. These lines are represented by various coordinates and these coordinates are represented by various individual points which have individual coordinates. But I am posing this question to you. Just think about it as to how, if any rectangular feature is to be represented, how many lines, how many coordinates are required. Just think about it. So you can see now here, I gave you the example of rectangle, but here the polygon is having few lines. So you can imagine as to when we say that points are individual coordinates, line is the different coordinates which are forming any linear entity, and polygons are various lines which are forming an area entity. So these are geographic information which have dimensions, the spatial dimension in the form of point, line and area. The method of representing geographic features by the basic graphical elements of point, line and polygon is said to be the vector method or vector data model, and the data are called vector data. Related vector data are always organized by themes, which are also referred to as layers or coverages. The example of themes can be the soil, vegetation cover, land use, transportation, drainage, political boundaries, etc., etc. For themes covering very large geographic area, the data are always divided into tiles so that they can be managed more easily. A tile is the digital equivalent of an individual map in a map series. This is what the advantage of spatial information. It is uniquely identified by a file name. Further, a collection of themes of vector data covering the same geographic area and serving the common needs of multitude of users constitutes the spatial component of a geographical database. The vector method of representing geographic feature is based on the concept that these features can be identified as discrete entities or objects. This method is therefore based on the object view of the real world. The method of representing geographic features by pixels is called as raster method or raster data models, and the data are described as raster data. A raster pixel represents the generalized characteristics of an area of a specific size on or near the surface of the earth. The actual ground size depiction by a pixel is dependent on the resolution of the data, which may range on the ground maybe a square meter, or it can be of several square kilometers also, because it is an area entity. So an area entity, depending on the resolution, can be a small like table or a big spatial feature like a cricket ground or the entire state boundary. So raster data are organized by themes, which are also referred to as layers. For example, a raster geographic data may contain the themes such as a vegetation cover as one layer, land uses as another layer, topography as third layer, hydrology as fourth layer, etc., etc. So raster data covering a large geographic area are organized by scenes, especially in the context of remotely sensed images. Now here I would like to point out that all the time when we are employing remotely sensed images in our spatial information, they would only come into raster format, because the remotely sensed images are only available in raster format, whereas we transform them in many cases for some specific analysis and some specific objectives. We transform them in vector format, but it comes in raster format also only. So the remotely sensed images, they are stored in raster data files where the image is obtained by. Now another example can be of raster data files are, if we scan any map, they would again be coming into the raster format. So when we are scanning, all the time the scan information, scanned spatial information, they come in raster model. So this raster method is based on the concept that geographic features are represented as surfaces or segments or regions. This method is therefore based on field view of the real world. This is a good example of raster data model. On the right side there is one picture which will give you a good idea of raster data model. This raster data model, they have tiny little grids, and each grid is representing three information. One is about its location on x-axis, another is on its location on y-axis, and third one is the attribute information. And that is how this raster data is arranged for representing any earth phenomena in the spatial information, in the form of spatial information. So raster data model is one of the variants of the field-based model of geographic data representation. These are made up of, as I am saying, grid cells. They are regular spaced with generally square shape, usually defined by a set of uniform adjacent pixels with each assigned a separate pixel values. Each pixel value indicates the characteristic of the phenomena. It represents, there can be two kinds of them, either discrete or continuous. So the discrete raster have distinct values. Now here I need to point out that this information about the raster data, we are talking about the pixel information, only about the attribute information. As I mentioned that the two other information, that is about the location on x-axis and y-axis, it would remain common for all kinds of raster information, for all kinds of raster data. So when we are talking about discrete raster and we are talking about values, it is about the attributes which the raster model is representing. So continuing with, the discrete rasters have distinct values, distinct category or theme. For example, one grid cell represents a particular land use or land cover class. Each thematic class can be distinguished and specific class is allotted. Whereas continuous raster are non-discrete raster with data changing gradually as represented in a slope map, elevation or soil distribution, etc. They are generally represented with fixed registration points, and each of them has their unique registration points. So in this diagram now you can understand very easily what we mean with raster and vector data. So to represent the real world features which exist either as object or phenomena, the objects are discrete and definite, such as trees, buildings, huts, buildings, etc. Phenomena are distributed over a large area such as temperature, soil, etc. These two forms lead to two distinct approaches. There are object-oriented based and field-based models. The object-based spatial database, those obtained by field surveying or by remotely sensed image analysis, photo interpretation, or even by digitizing, bringing the information into the digital format. They are generally represented as coordinate lines and termed as vector data model. When the spatial database is structured on field-based model, the basic spatial units are different forms of tessellation, regular as digital elevation model or irregular as tin model. They are termed as raster data model. Identification of features from the real world followed by selection of appropriate spatial data model, raster or vector, and their structures, they are the key to the spatial model building process.